So the quadratic formula won't take long, okay? The formula is going to be provided for you, so you don't need to memorize it. All right, so I'm not that worried about it. It's just making sure you know how to use it, when to use it, and there's some important information given in the quadratic formula, okay? So the biggest thing that's going to be messed up the most is it's not in standard form. As long as your quadratic in standard form, then quadratic formula is easy to use. But it's when you have a quadratic not in standard form that you get into trouble. You try to find your values of A, B, and C and plug them in, and they're not going to be right because it has to be in standard form. But once you have it, we're just looking at the coefficients and the constants. I should not see any variables in here once you plug in your values. I shouldn't see any variables. I should see the coefficients, I should see the constants, and nothing else. Plug it in, evaluate it. The other big thing is with a lot of our answers, we are not going to get nice, pretty numbers, okay? Because if we do, then that means we probably should have factored it to begin with. It would have been faster to factor than using the quadratic formula. Be very, very careful when you're using the quadratic formula, especially the more stuff you're plugging into your calculator, the more room for error that you have. So you need to be very careful about simplifying and evaluating it. You'll notice a lot of times when I do it in little chunks. Like I like to simplify what's under the radical first, and then simplify my denominator, and then start simplifying the numerator and denominator respectively, depending on the type of question that we have. Okay? So we have to make sure our equation's in standard form, and then identify A, B, and C. So is this equation in standard form to start?
Yes.
Yes. What's my value of A? 4. The coefficient of the squared term. What's my value of B?
Minus 11.
Negative 11. The coefficient of the linear term. What's my value for C? Negative 3. Okay? Now, when I ask you to show your work, this is what I want to see on the next step. Okay? So x equals negative b plus or minus, because we have both with radicals, negative 11 squared minus 4 times negative 3 over 2 times 4. All I did is I plugged in those values for A, B, and C. So when I ask you to show your work, that's what I want to see. Outside of that, it's just calculated. Okay? Unless we have to simplify radicals, then there's some more stuff in there. But as far as just using the quadratic formula, I need to see this filled in.
So you use a calculator?
You just calculate for everything. I mean, yes, you could plug this whole thing into your calculator, but if you do, you're probably going to make a mistake somewhere. It's really easy to mess up this part, or you can't do the plus or minus, so you have to do it individually. There's a lot of places where it could go wrong if you're not very careful, and you won't know whether you get the right answer or not, because most of our answers are going to be decimals. So that's why I like to do it in chunks. Okay? So I like to do under the radical first. So negative 11 squared is what? What's negative 11 squared? 121. Okay? So I got 121. Okay? And then 4 times 4, or I'll do negative 4 times negative 3. The calculator will do it for you. I'm just doing it in chunks. You type negative 4 times negative 3. Okay? And since I have a minus and I have a negative here, that ends up becoming plus. Okay? 21 plus 48. What's 21 plus 48? 169. And then 2 times 4, you get 8. Okay, so that's kind of that first step I like to do when I'm simplifying that way. I have less room for error. Just under the radical, simplify it. And then we're going to go ahead and look and start to clean up and simplify our radical even further. Okay, so negative 11, that becomes positive. Plus or minus. Can I square root 169? Yeah, what's that give me? 13. Okay, so I have 11 plus or minus 13 over 8. Remember, our radicals give us two answers. We have the positive and negative, and so we need to treat this as two separate fractions. 11 plus 13 over 8 and 11 minus 13 over 8. 11 plus 13, 24 over 8, which simplifies to 3. 11 minus 13, negative 2, which simplifies to negative 1. Okay, so x equals 3 and negative 1/4.
Is that? Oh, that's
Yeah, I think messed up a little bit. Negative 1/4 and 3. Okay. All right. Standard form? No. What do I need to do to get it in standard form? Subtract the 14x. So I've got 2x squared minus 14x plus 19 equals 0. I've got some two-digit numbers there, so you may want to keep your calculator handy. Or you can do it long way. I don't care. What's my value of A?
2.
Value of B?
Minus 14.
Negative 14. Value of C?
19.
19. Okay? So, x equals negative 14 plus or minus negative 14 squared minus 4 times 2 times 19 over 2 times 2. Alright, so let's simplify the radical. Negative 14 squared. 196. 4 times 2 times 19. 196 minus 152. So that's under the radical. Okay? And I already did the negative 14 to simplify to 14. Did the 2 times 2 to 4. So you can kind of do a lot of those together. Alright? Now we need to simplify a radical, because 44 is not a perfect square. How can I simplify the square root of 44? 4. Okay, so I have 14 plus or minus the square root of 11 times 4 over 4. So the radical becomes what?
14. 2 square root 11.
2. Right? Now, I can't add 14 and 2 square root of 11 unless I get unless I want a decimal value, which I don't. But there's one other thing I can do to simplify. Yeah.
Why did you pick 11 and 4?
I need a perfect square factor of 44, and I know 4 is a factor of 44, so 4 times 11 gives me 44. I can square root the 4, and I can leave the 11. 11 doesn't have any factors of the squares to simplify it.
So it's like
Then you have to factor 22 again to get you a second 2 so that you could pull out the 2. If you factored it, if you took 44, did 2 and 22, and then factored it again into 2 and 11, well, 2 times 2 gives you the 2. Alright?
Could you simplify and make that 7 over?
So, what we want to look at, there's a couple different ways of doing it. All three terms have a common factor of 2. So I can simplify all three of those terms. I don't care about what's in the radical. I've got this factor outside. Okay? All of those can be simplified by 2, leaving me with 7 plus or minus the square root of 11 over 2. That's fine. That's good. If we have complex numbers, then there's an additional thing that we have to look at. But as far as our real numbers go, we can just leave it as that fraction, 7 plus or minus the square root of 11. You need to make sure that you can simplify it, though. All three of those terms have to have a common factor in order to simplify it. If this was just 14, let's do a side note. If this was just 14 plus the square root of 11 over 4, okay? I didn't have a 2 in front of the root, okay? If I have this, that does not equal 7 plus or minus root 11 over 2. I can only simplify these if I have the same in all three. But what I can do instead, and we talked about it briefly when we dealt with our complex solution, is I can write it as 2 separate fractions. So I could write it as 14 over 4 plus or minus the square root of 11 over 4, and then I can simplify that, but I can't simplify anything with the square root of 11 because it doesn't have a common factor with it. Okay? We'll see this more with our complex numbers because our complex numbers require us to do this. Usually when we're dealing with a quadratic with a real answer, we just stop there. Okay. Or in the case of the first example, we would stop here. Not first example, the last one. All right. Okay. All right. Standard form?
No.
What do I need to do?
Distribute.
I need to distribute first. Okay?
You get x squared plus x plus 5x plus 5.
Good. So 6x plus 5.
And it equals 10x.
Good. Now what?
And then you get x squared, x plus 5. You gotta combine them.
I did that.
Oh.
Subtract the 10. So negative 4x plus 5 equals 0. So what's the value of A? 1. What's the value of B?
Negative 4.
What's the value of C? 5. Doing the whole thing again. Then what'd you get? What'd you get for x then?
Oh, I don't know. I didn't do it. Like I said, I know how to do it. I don't know how to do it, so can we do it?
Absolutely. I was going to do it anyway. B is negative 4, so we plug that in. Plus or minus negative 4 squared minus 4 times 1 times 5 over 2 times 1. Simplify the negative 4 to positive 4. 16 minus 20 over 2. What is 16 minus 20? Negative 4.
Oh my god, they have an ID.
I know. It's like I knew there would be different types of answers, and I made sure to include them in the notes. Factor out the negative 1. I got 4 plus or minus. Factor out the negative 1 from the 4. Okay. What's the square root of negative 1? I. What's the square root of 4? So I have plus or minus 2i over 2.
That's it? Oh, and then you gotta
I want to say something very specific, okay? And it kind of goes back to this, okay? I'm going to reference this with this. When you have complex numbers, even if they all have a common factor, just get in the habit of writing it as two fractions. 4 over 2 plus or minus 2i over 2. And it's going to get you set up to make sure that you simplify it properly every single time. This is going to happen to be where our denominator goes away because it's the common factor for both terms in the numerator. Yay! But it's not always going to be that case. So if you get in the habit of writing it as two separate fractions, you're going to make sure that you have a better chance of getting your complex number into a plus bi notation, which is what your complex numbers need to be written in. A plus bi notation, where we have the real part and the complex part. So that's why I want you to get in the habit of splitting those two fractions and then simplifying, which is an easy step. 4 divided by 2. 2. And then 2 divided by 2. 1. So I'm left with 2 plus or minus I, which is still in the form a plus bi. A plus bi.
What's the B?
It's a 1. Well, not imaginary 1, but
So can you explain? We got 4 plus or minus 2i.
so from here to here. Okay. So square root of 1 times 4, that gives me square root of 4, right? Okay. So if I have the square root of negative 1, that equals I. It's our imaginary number. I can't square root of negative. Then I also have the square root of 4, which is what?
2.
2. So I have 2 and I have I. I just want the 2 first and then the I. Alright? And then from there I just simplify my fractions. Okay? Any other questions, comments, concerns on that? Okay, so that pretty much covers, remember when we talked about food and distraction in the beginning of class? Like, alright, so the other thing that we're going to talk about is the discriminant. Okay, discriminant is a part of the quadratic formula. It's the part that's underneath the radical. It's called the discriminant. We use that to help us determine the number and types of solutions. The discriminant is actually really useful to use to figure out in the beginning whether or not you can factor a quadratic. Okay? Depending on the result of the discriminant will tell you, can I factor this quadratic? And if not, then I have to either use completing the square or quadratic formula to solve. Okay? So again, we've got standard form, and this is just the part that's under the radical. And when we're using the discriminant, we're looking at the type of number we get, which will tell us the number and type of solutions. If I do the discriminant and I get a positive number, that means I'm going to have a real solution. It will be real as long as the discriminant is positive. I will have 2 real solutions. 2 real solutions. Whether or not it's rational versus irrational depends on whether I end up with a perfect square or not a perfect square. So if my discriminant ends up being something like 4, or 9, or 16, or 25, etc., okay, then I will always have 2 rational solutions. That means I can also factor that quadratic. All right? Sometimes I want the factors rather than just the roots. If it's any other number other than a perfect square, then it's going to be 2 irrational solutions. If my discriminant equals 0, so I have my square root and I end up doing 16 minus 16 and it equals 0, then I have 1 rational solution. 1 rational solution. Positive, 2 positive perfect square, 2 rational. Positive non-squares, 2 irrational. 0 is 1 rational solution. And the negative is going to give me complex solutions because negative is going to be the I when I square root it. Okay? So being able to use the discriminant to determine, hey, which of these types of answers will it be? I want to be very clear. When I ask you to find and use the discriminant, if I see you solving for x, 1, you're doing way more work than you need to. And 2, I'm not giving you credit. Okay? Use the discriminant to predict the number of solutions. All right? So find the discriminant. B squared minus 4AC. What's my value for B? -1. -1 squared minus 4 times 10 times -2. So I've got 1 plus 80 to equal 81. So 81 is the value of the discriminant. So, is it positive?
Yes.
Yes. So then it's got to be either 2 rational or 2 irrational. Is it a perfect square?
Yes.
So then it's going to be 2 rational solutions. Okay? It's positive and a perfect square. 2 rational solutions.
Where'd you get 80?
Where did I get 80 from? 4 times 8 times -2 gives me -80. If I'm subtracting -80, it becomes positive 80. I added that to the 1 to get 80.
How did we get that formula?
It's in the quadratic formula. So I'm not going to give it separately. It's under the square root.
I don't know how you got 2 really big numbers from 10 and 42.
What's 10 times 4? Times 2. 81's a perfect square.
80 plus 1. Oh, it's the
Alright. Okay. Standard form?
wait, no.
The formula.
Wait, so what's the answer?
Yep.
Because it's a perfect square.
Because it's a positive perfect square.
Oh.
Okay? Garcia said find the discriminant. Hey, there's the discriminant. 81. Use it to predict the number and type of solutions. Okay? So because it's a perfect, positive perfect square, that means I will have 2 rational solutions. Since I have 2 rational solutions, that means I can solve by factoring. 2 rational solutions means I can solve by factoring. Anything else, well, 0 means I can solve by factoring too. But irrational or complex numbers, I have to use the quadratic formula. Okay? Standard form? Get it in. Okay? Discriminant formula, b squared minus 4ac. What's my value of b?
-1.
What's my value of a?
3.
And c?
-7.
Okay? What is 4 times 3 times -7?
84.
So my discriminant is 85.
It's positive, but it's not a perfect square, which means that it has to be
2 irrational. 2.
You're right.
Well, they are very different. Okay? 2 irrational solutions. So does that mean I can solve by factoring? Or do I need to use quadratic formula?
You need to use quadratic formula.
Gotta use quadratic formula.
I just love it.
Hey, what's up? Yes. Okay. Okay, yeah, we'll do. Alright. So I have to use quadratic formula. Quadratic.
Wait, who is that?
The yearbook teacher.
Okay, sure.
Alright. For C, standard form,
No, minus 40.
subtract our 40x. 16x squared minus. How can we do this? Root. Minus 40x plus 25. Okay? Alright. B squared minus 4a. Why are you not writing something? What was that? 4 minus 4.
Times 8.
Okay. What's my B value?
Negative 40 squared.
A value? C value? Okay. What's negative 40 squared?
Oh, 600.
80. Oh. Oh yeah, I mean, because I forgot.
What is 4 times 16 times 25?
Negative 16.
What's 1600 minus 1600?
0.
How many solutions?
No, one rational solution.
One.
So is there a possibility for there to be one incorrect?
Why is it one rational? You have to remember, like,
Yes, you do.
it's not going to be on the test.
Well, it'll say how many and whether it's rational, irrational, or complex.
But this chart isn't going to be there?
Oh, you have to remember like 4 things. Okay? The reason you get one rational solution is because this is a perfect square trinomial.
Could you just look at it and tell them?
Yeah, but I still want you to find the discriminant. Perfect square. This factors to be 4x minus 5 squared. So if I solve for 0, I'm going to get the same number twice. That's why there's only one solution. So that only happens with perfect square trinomials, is if your discriminant is 0, it's one rational solution. And I just factored it, which means, yes, we can solve by factor. So if you have rational solutions, you can factor. If you have irrational or complex, you have to use your quadratic formula. Okay? All right. We did it. Good job.